So the first part of the beginning of the unit is going to be a review of inverse functions from Algebra 2. Back in Algebra 2, you guys talked about inverse functions. Remember, graphically there's a relationship between a function and its inverse, and that is that they are reflections of each other over the lines y equals x. And remember, you can find the inverse function by switching the x and the y in the equation and then solving for y. So remember the notation we use for an inverse function. You'll see this function notation with a negative first exponent. Remember, this is the one time when you see a negative exponent that you do not use the reciprocal function, which is not equivalent to 1 over f of x. You don't take the reciprocal. So for example, if I give you the function f of x is equal to x to the third, you can find the inverse by switching. Remember, f of x equals x to the third is the same as y equals x to the third. So you can find your inverse by switching x and y. So x is equal to y to the third, and then you can solve for y in this case by taking the cube root. So then my inverse function is going to be the cube root of x. So that's how you can find the inverse. Graphically, remember, like I mentioned, there is a graphical relationship. They are reflections over your line y equals x. So here's my line y equals x. So again, remember what your cubic function looks like from Algebra 1 with negative 1, 0, 0, 1, 1. So again, your cubic function looks something like this. So this is my f of x. So then if I sketch my inverse, remember my cube root function is going to look something like this. And this is my inverse. So you can see how they are inverses of one another. Remember, there was a composition theorem you talked about last year in Algebra 2. If you take a function and do a composition with its inverse, it's equal to x. So for example, given my inverse function of the cube root of x, if I do a composition and plug my inverse into function f, I would end up taking the cube root of x and raising it to the third power, which is equal to x. Remember, this is the only time your composition is commutative. If I take my function, which is my x to the third, and I substitute it into my inverse function, then I would take the cube root of x to the third, which is just going to give me x. Remember, something happens with the domain and range of a function and its inverse. Remember, the domain of f of x becomes the range of your inverse. Because you switch x and y, the domain and range are going to switch. The range in f of x becomes the domain of your inverse. Now, the one thing that we have to understand before we get into our inverse trig functions, not all functions, even though you have a function, the inverse may not necessarily be a function. So in order for an inverse to be a function, it must be a function that is one-to-one. And the way you test for a one-to-one function is that we know that all functions have to pass the vertical line test. Remember from Algebra 1, in order to be a function, it has to pass your vertical line test. But for a function to be one-to-one, it also has to pass your horizontal line test. Now, if a function is not one-to-one, and we want the inverse to be a function, we can restrict the domain and force it to be a one-to-one in order to find the inverse, which is a function. So for example, let's take a look at your function x squared. Again, that's my parabola, vertex at 0, 0. So we know that this is a function. It passes the vertical line test. The vertical line will only intersect the graph at one point. However, notice it does not pass your horizontal line test. This is not one-to-one. The horizontal line is intersecting your parabola at more than one point. So in order to force my inverse to be a function, what I can do is I can take my function of x squared and I can restrict the domain. I'm going to say, okay, so here's my graph of x squared. Let me restrict the domain so that my x values are greater than or equal to 0. So looking at this function, if I just want to look at this where my x values are greater than or equal to 0, I'm only looking at the right-hand side of the parabola. So now notice when I restrict the domain, still a function, still passing a vertical line test, but now it's 1-to-1, because anywhere I draw a horizontal line, it's going to intersect my graph at exactly 1 point. So this is 1-to-1. So when we get into our trig functions and we talk about their inverses, a similar concept is going to be used for sine, cosine, and tangent. They are all functions, but they're not 1-to-1. Therefore, what we're going to be doing is we're going to be restricting the domain and force them to be a 1-to-1 function in order so that their inverses will be functions.